Okay, welcome back everybody, and last class we talked about two really important pieces of information. This piece of part right here you don't have to write down, I just want you to listen for right now. So today we talked about two things. We talked about mean, we talked about standard deviation. Okay. What is mean? Mean, it is the average. My variable for mean is x bar. We have another variable for mean. My other variable for mean is a u with a tail. Okay? Standard deviation. All right? Standard deviation is the average distance each point is from x bar. X bar is the mean. Okay? My variable for standard deviation is an O with a hat. This is called sigma. Some people also like to think it looks like a golf club, so you can call it golf club. You need to know that this variable means standard deviation, this variable or this variable means the mean. Okay? How do we find the mean? We add up our numbers. We divide by number of numbers. Okay? How do we find the standard deviation? It's a little bit more annoying. It's the steps on the front page of your notes. If you are not in class today, the blank, the filled out part of your notes is not in a video. It is in a document that you can copy the front part down. So let's talk about standard deviation. Okay? So I'm going to take an example, 1, 2, 3, 4. Okay? So what standard deviation tells me is the average distance each point is from the mean. So it's telling me how far away, on average, each of these values are from my mean. So if I calculate my mean of this data set by just adding 1, 2, 3, 4 and dividing by 4, you get x bar is 2.5. So this tells me on average, I'm going to find on average how far each of these data values are from 2.5. When I'm talking about distance, okay, zeros here, negative or positive 3, that's 3 units away. Negative 3, that's also 3 units away. Distance is never measured in negative. You can't have negative distance. So when you're finding the distance of something, you're just always going to make your answers positive, and that's where some of us might have gotten a little lost today. So let's go back to our notes here, which is not this, it's over here. And let me scroll down. Okay. So we did this front part. In class, you are working on this problem right here. I want to do this together. Okay. So if you've already done it, I want you to follow along and make sure your answer matches my answer. So it says below are the scores of a science test. Determine the mean and standard deviation. My variable for mean, x bar. My variable for standard deviation, sigma. Okay. So first you find the mean. So first I'm going to come over here and find x bar. Add them all up. Divide by 5. You get 78.8. So that's my mean, step 1. To find my standard deviation, it's a bit of a process. So I found my mean. So I'm now going to find the distance each of these values are from 78.8. So I'm just going to take 78.8 and subtract each of my values from it. So you get 78.8 minus 57 is 21.8. 78.8 minus 65 is 13.8. 78.8 minus 83. Notice you get negative 4.2. I'm going to make it positive 4.2 because I'm talking about distance. Distance cannot be negative. So it's 15.2. This one's 16.2. We write a note. Distance is never negative. Okay? So from here, I'm now going to square all of these numbers. Okay? 21.8 squared. You get 475.24. 13.8 squared. You get 190.44. 4.2 squared, 17.65. 4. 15.2 squared, you get 231.04. 16.2 squared, 262.44. Okay, so from here, you are now going to take these numbers and find the average of those numbers. How do you find the average? You're going to add all of these up and then divide by 5. All right, so let's add them all up. 475.24 plus 190.44 plus 17.64 plus 231.04 plus 262.44. Hit enter. Divide by 5. You get 235.36. So now my last step, I'm going to square root it. So my standard deviation is 15.3. Okay. So what this tells me is on average, each of these values over here is 15.3 units away from my mean, which is 78.8. That's what standard deviation is. So what's the point of standard deviation? The point of having a standard deviation is to be able to approximate the likelihood of something happening. So if we go back to a box and whisker plot, right? Okay, each of my percentage of my box and whisker plot was worth 25%. What if I wanted to calculate 33%? What if I wanted to calculate 40%? Okay, my box and whisker plot only does 25%. It's not good enough. So we're going to use what's called a bell curve to better represent our data. Okay, so pictorially we use a bell curve, and this is what it looks like. It looks like a bell. Okay, so a bell curve is broken up into pieces. Now notice my bell curve, I can draw a line of symmetry straight down. The center of my bell curve is always my mean. My variable for mean is x bar. Okay, so now notice you have tick marks. So you have 1 tick mark, you have 2 tick marks, you have 3 tick marks. Over here on the left, you also have 3 tick marks. So to the right, this is 1 standard deviation away from my mean. This is 2 standard deviations away from my mean, because it's my second tick mark. This is 3 standard deviations to the mean. Now notice it's to the right, so it's positive. Now if I go to the left, I'm negative 1 standard deviation away. If I go to the left another one, I'm negative 2 standard deviations away. If I go to the left one more, I'm negative 3 standard deviations away. Okay? Now a bell curve continues on forever, so it goes on forever infinitely in either direction. But notice the majority of my data is where my bell curve is, where the big part of my bell curve. So if you look between my first standard deviation to the left and to the right, this piece right here is worth 68.9% of my data. And if you keep going, it keeps increasing. If you include 2 standard deviations away, so from here, that's 95% of my data. If I keep going, it's even more. So it helps me accurately calculate my percentage, my likelihood of something happening. Okay? So if we look at an example, it says given a data set with a mean of 20 and a standard deviation of 3, draw a bell curve. All right, so I'm going to draw a bell curve. I'm going to start with my number line. I'm going to draw my bell curve the best that I can. I'm going to draw my line down the middle. My line down the middle is always my mean. What's my mean in this problem? 20. You now have to draw 3 tick marks to the right, 3 tick marks to the left. Okay? So if I go 1 tick mark to the right, that's 1 standard deviation away. So since my standard deviation is 3, I'm going to take my mean and I'm going to add 1 standard deviation to it, which is 20 plus 3 and make that 23. Okay? Now, I'm going to then go to my next tick mark, I'm going to add 3 more, because that's my standard deviation. 26. Add 3 more. That's 29. Okay?
Mr. Mitchell, if you're still in the building, please call the front office, Mr. Mitchell.
All right, pardon that. So now we went to the right. So every time we increase by 1 more standard deviation. So notice from 20 to 26, that's 2 standard deviations away. And 2 standard deviations, that's 2 3s, which is 6. 20 plus 6 is 26. So now let's go in the opposite direction. So when I go to the left, I subtract one of my standard deviations. So subtract 3, you get 17. Subtract another 3, you get 14. Subtract another 3, you get 11. Okay? So the big part to get out of this is your mean is always in the middle, and you increase by 3 standard deviations to the right and 3 standard deviations to the left. And how you get to those values is you just keep adding or subtracting whatever your standard deviation is. Let's look at another one. So the given data set has a mean of 15 and a standard deviation of 6. Draw a bell curve. So my mean is x bar, my standard deviation is sigma. So okay, let me draw my bell curve. Draw the best that you can. So the middle of my bell curve is my mean, which is 15. You're then going to go 3 units to the right, 3 units to the left. Doesn't matter where, just as long as it looks like something similar to mine. So to get to this first unit to the right, you're going to add one of your standard deviations. So my standard deviation is 6. So I'm going to take 15 plus 6 and I'm going to get 21. To go to my next one, I'm going to add another standard deviation. So 21 plus 6 is 27. To go to my third one, I'm going to add another one and get 33. Okay, look at the left. Now if I go to the left, I'm not going to add my standard deviation. I'm going to take my standard deviation away. So 15 minus 6 is 9. 9 minus 6, 3. 3 minus 6, negative 3. All right, so looking at these examples, what do you notice? Okay, let's go ahead and highlight this. What are some things you notice? The values to the right, oops, to the right get added. The values to the left get subtracted. All right. Another thing I want you to notice, the x bar is where? Is always in the middle. So when I'm drawing a bell curve, the point of drawing a bell curve is to be able to approximate the percentage of something happening. We don't get to do that yet. Right now we need to be able to make a bell curve. So let's look at the last example. It says, given a data set with a mean of 15 and a standard deviation of 5, draw a bell curve. Okay, so number line, bell curve. Where do I always start? The middle. What's the middle? My mean, which is 15. 3 units up, 3 units down. What do I increase by? My standard deviation, which is 5. So 20, 25, 30. To go in the reverse direction, you subtract. And I have my bell curve. Okay? So now, what if I asked you a question like this? What value is 2 standard deviations to the right? Okay, so 2 standard deviations to the right. So the middle is my mean, so I'm going to go 2 tick marks to the right. 1, 2. So that's my second standard deviation. So what value is 2 standard deviations to the right? 25. Oops, let's write in pen. What value is 1 standard deviation below x bar? So if I'm talking about below, am I talking about left or am I talking about right? Well, I'm talking about left. So I'm going to go 1 standard deviation to the left. So here's my mean. Here's 1 standard deviation to the left. Okay? That is 10. Think of standard deviations like steps. I'm 1 step away from the mean. I'm 2 steps away from the mean. Okay? So because what is 2 values to the right? 2 standard deviations to the right, 2 steps away. What is 1 standard deviation below? I'm 1 step below. All right, one last question. How many standard deviations? How many standard deviations is 5 from the mean? Okay, so let's look at 5. 5 is right here. So how many steps away is it from the mean? It's 2. Now is it 2 above or 2 below? It's 2 below. Okay. So the point of being able to draw a bell curve is being able to answer questions like these. And that's where we're trying to get to. Okay. So this last example, I want you to do on your own. Okay. Now, one thing I want you to do, round all answers to whole numbers. Okay? So you're going to find the mean, you're going to find the standard deviation, you're going to draw a bell curve, and then you're going to answer this question. And another question you're going to answer before this question is let's do what value is 3 standard deviations above the mean. Finish this example, answer these questions, and then you are finished. If you have questions, come see me, and I hope everybody has a great day.